All right, so we're back, man.
So long.
Yeah, nice to see you again, buddy.
Absolutely. 2 months.
2 months off. Sorry about the delay, but we have good excuse, huh?
We did, last month we did the GoingNative thing. Was
Yes.
amazing. GoingNative 2012. I'm not talking about the series we are doing in Channel 9, but the conference organized.
That was awesome, man.
A lot of attendees, not just on site, but also people online.
Absolutely. There were a lot of people watching live.
Still today, because unlike other C++ conferences, the sessions we had in the agenda are still there in Channel 9, so there's a link, like
somewhere over here.
Yes.
But yeah, they're all there in high definition, multiple formats. Download them, watch them. I highly recommend it. I mean, it's, in my opinion, it's the best source of C++ 11 information and beyond.
Yes.
That's out there. So go ahead and watch that. It's really good stuff. I want to shout out to the attendees for asking such excellent questions. And the energy in the room was just palpable.
Yeah.
It was awesome.
I was actually getting from Twitter, in the tag, GoingNative.
Found GoingNative.
The questions that were coming, and also comments people were doing there. I had a lot of fun watching the different impressions people had about that. In particular, called my attention some comments people made about Andrei, because people tend to associate Andrei with the D language.
Yes.
At the level that some people think he was the creator of that. So Andrei was there, but of course he was in the conference. He was to talk about C++.
Exactly.
So,
and I mean, let's be honest. I mean, he is an exceptional C++ developer, engineer.
He wrote a lot of books about that.
Oh, he did, and he writes a lot of code.
He's still writing books. I mean, he plans to renew, the books.
Totally.
Now that C++ 11 is the new standard. So.
Yes. So now, in the audience at GoingNative was Walter Bright, who is the creator of D.
Okay.
He's also the guy who wrote the first C++ compiler that didn't compile to C first. Rock and roll, man. So he's great. It was great talking to Walter. So I got both of them together, and we talk about D. We're going to talk about a different native language than C++. It's going to be D. We're with the creator of the language, Walter Bright, and the co-creator or co-evolver of the language, Andrei Alexandrescu. So Walter, starting with you, why did you create D, or why did you go down the path of inventing a new native language?
Well, I really like native languages. I've been involved in the C and C++ compiler business for a long time. And there have been a lot of advances in programming language theory and ideas and all kinds of great new things. And I really wanted to create a language that incorporated all those productive new ideas into a native language and made them available to the people who really like to work with native languages like I do. Things like functional programming techniques, advanced metaprogramming techniques, and other ideas.
Excellent. And so, Andrei, when did you get involved with the D project?
It was a dark and stormy night. It actually was a dark, probably not stormy night. When Walter and I got to talk, we knew each other for a while already, and we got to talk in a bar. And I said I have my own interests in on the programming languages landscape, which would be advanced generic programming, not necessarily advanced, but rather making simple things simple and such. Because it looked to me that a lot of things that I wanted to express in C++ that were relatively simple suffered because of undue complexities and hacks that are inherent and need to be done in C++ to achieve rather reasonable abstractions. So I was actually embarked to define my own language. And Walter and I got to talk, and it boiled down to a very interesting compromise of sorts. And it went the following way. He said, "You know what, Andrei? I appreciate your ideas. I'm there. So I like them. But when you define a language, the interesting tidbit that many people starting it don't know about is that there's a lot of just work to get to first the simplest things in place, like just the basic code generation pipeline, the basic constructs of the language, make sure it all holds water in its simplest incarnation. So there's a lot of work just to get to the basics. And many research languages and implementations thereof suffer from the fact that nobody wants to sit down and do all that stuff. So essentially they are poor quality, low efficiency implementations. Interesting ideas, but lacking a sort of a practical angle to them. And D was already in good shape for the basics. It was in excellent shape. Had good modules, had good code generation. Was a very smooth, very good compiler, and it was ready for saying, so we want to improve, add all these great ideas in programming language design and implementation to it, and I think it went over pretty well.
Excellent. Now, what are some of the things that what are some of the problems that D solves that C++ doesn't, or can't, or doesn't as efficiently or effectively or as productively? That's my question.
I mentioned functional programming idioms before. D has, for example, you can write pure functions that are verifiably pure. And this is real important for doing multi-threaded programming. And for Lambda functions, it's very nice that they're pure and that the compiler can check it, because then you know that you don't have to rely on code review to find these problems with it. You don't have to rely on trying to educate your D programmers to not make mistakes, which generally does not work.
Okay.
It's much better to have language guarantees about things than it is to rely on trying to educate programmers to not make mistakes or use certain constructs. You want to be able to run the compiler and have it be able to guarantee certain properties about your code. So a lot of the focus on D is being able to specify interfaces, function signatures, purity, constancy, immutability, whether data is being shared with another thread or not, all through compiler guarantees, as opposed to just simply hoping that your developers got it right.
Interesting. So you sort of force people to go down the right path. By the way,
it's not forcing. Actually, actually, you're touching on a very interesting angle here, because it was Walter's great idea to add a lot of deduction in the compiler. Essentially, many language concepts. For example, the obvious example is lambdas, because lambda by definition is seen, has a body. It's not separate compilation. It's there, right? So we have recently added this great feature in the compiler that is user level invisible, which is deduction of properties of functions. So our first shot at all of these nice properties, purity, constancy, sharing, all the stuff, has been essentially require user annotations to do so. But the more advanced approach, which we've done a part of and we're still working on, is to add deduction by the compiler and silent recognition and use and exploitation in a good way of properties of code without the user having to annotate. And a very good example is reducing constancy, impurity, and no throw. All of these good things, which do happen for lambdas, do happen for templates, because we have a white box approach to templates, so there's no separate compilation, which could be seen as a disadvantage, but at the same time, when you think of it, the code of the template being there means you can actually prove properties about it that the user didn't sit down and didn't have to sit down and write.
excellent.
It's also important to realize that these properties that the compiler enforces are not a straitjacket. After all, D is a systems programming language, and there is a back door that you can break the type system and do what you want to do. You can forcibly reinterpret cast to do from one type to another. This is disabled if you mark code as being safe. It doesn't allow you to do that. But if you're willing to write system level code, D will let you write system level code. But it's not going to happen by accident. you're going to have to deliberately say, I want to do these, I want to break the type system, I want to go under the hood, I want to do this. It's not going to happen because you made a typo.
Okay. But I mean, that sort of kind of begs the question, if you give a developer an escape hatch, chances are they're going to use it because maybe they're going to think, oh, I'm going to be more performant, or oh, I'm going to be able to solve this algorithm faster. And then what you have is you break your guarantee of safety, which is
Right.
one of the things that you've stated is very important about your language.
Right, but it's very easy for the quality assurance team to look at the build system and look at the code and see if those guarantees are broken, because you can mark code as being safe. And if that code is not marked as safe, it is assumed to not be safe. And the QA staff, what they have to do is look to see if it's annotated properly. If it's annotated properly, then the compiler is going to give you a guarantee about that. And so it leaves a lot less space for static analysis programs. From what I've read about static analysis programs, they also tend to give a lot of false positives, which there's a lot of boy who cried wolf problems with them, and they create a lot of work for the QA staff and the engineering staff who've got to sort through it and figure out, what's real and what's not. With D, one of our principles, it's a binary thing. It compiles or doesn't compile. None of this wishy-washy warning kind of stuff.
Interesting. It's
right or it's wrong.
Okay.
We want to make it easy for the QA staff to manage these things.
Yeah, and let me add that I think you're making this this interesting point where the risk of transgression. Just because something is available isn't it going to be used, and as Walter said, I think the risk of transgression is much lower in D than in C++, for example, because what happens in D, it has a sort of a clearly, pretty clear subset of what is safe and another clear subset that's not safe. And in between there's a world of trusted code, which is connection with the operating system, and some certain things are safe, but you can't prove it statically. So the risk of transgression by mistake or by sort of the road to hell that you kind of slowly walk on the mythical paved road is much more difficult, because there are pretty clear paths to cross that hopefully large applications are going to not take, because my belief is that a good large application is going to have an absolute minimum of systems level code. Absolute minimum could be 0, could be small, could be depending on the domain, but then a large portion of the application should be safe. It should be should be provably safe, should be memory safe, should have all these nice properties and guarantees of memory safe programs.
For example, let's take pointers.
Okay.
Whenever you increment a pointer, you have a potential safety problem. And it's nearly impossible for a compiler to prove that incrementing a pointer and then dereferencing it points to valid memory and is safe. So what we've done with D is look at what people use pointers for and have safe alternatives for those uses, like we have bounds checked arrays, for example, and reference types. Now you can still do pointers, but you cannot increment or do arithmetic on pointers in safe mode. You can only do it in code that's marked as system code. And so that's kind of the classic example. You can't do inline assembler when you're writing safe code.
Okay.
But when you're writing system code, you can, D has an inline assembler in it. You have access to the full instruction set. You can do whatever you want with it.
Now, that's actually really interesting, because when you think about systems programming languages, usually what they end up doing is maybe scaring away isn't the right word, but they're going to scare away sort of the apps developer, right? The person who doesn't know what assembler is, let's say, but can build a data stacking app that goes out to a web service, gets some data, paints a picture, and moves along. But maybe that could be built on top of a system where there is somebody who knows what they're doing to target the hardware. So D is really for systems programming language. I'm just hypothesizing. Is it a systems programming language for the masses?
Yes.
Is that your goal? And if that is, why does a native language matter for the masses?
because everybody wants performance.
Okay.
Why you want native code? A native code app is going to start up fast. If you're targeting a low-powered device, you really will be wanting what kind of powerful compiler can you have on a very low-powered device. You're going to want to compile it on your powerful machines you have at work, and you want to put a pre-compiled binary on that low-powered device. So you can't afford to waste any cycles trying to JIT things on those underpowered, or people are always trying to get as much as possible out of those machines, and throwing that they've got to have a compiler and an optimizer on top of that is asking a lot. If you're compiling on a desktop, you're not constrained by memory limitations or time limitations when you really want to get optimal code generation. And on a small machine like that, you don't have much memory, you don't have much time, the user's not going to be pushing a button on their phone and is going to wait for it to JIT the dialer. It's not going to work.
I think there's a lot of making it look easy. That's not easy in your question, because actually, let me put it this way: I could write a small script in Z Shell, Python, Ruby, or D. I could write a small script, and very often I choose either Z Shell or D, because Z Shell is giving me a sort of a high level, not Z Shell in particular, but a shell scripting language. It's offering me a very high level of looking at things, which is one file at a time, one process at a time. I pipe things around, I munch data, whatnot. Okay, good. But then I want to do some processing, like, I want to do some real, like, hash table. I need a hash table. I need some, interaction. I need some computation to go on there. And I could choose, for example, D or Python or Ruby or any other scripting language. And very often it just turns out that there's not so much more to write for the equivalent D script. And it's also faster to boot. There's the compilation time is not an issue for even a medium-sized program. So definitely a short program that's a couple of hundred lines. It's going to be absolutely immeasurable. So essentially, I'm going to have the program. It's going to run fast. It's going to load fast. It's going to be fast. It's going to also be easy for me to write. But it does look easy. It's not easy. It's not easy. That being said, let me make an amendment here. There is an issue that we currently have, and by this I'm appealing to our our list, your public. We do have the issue of batteries included kind of library style. We don't include all batteries. We include the zinc and the AC, then you make your own battery, so to say, because. For example, in Python, it's an absolute slam dunk to use OpenSSL, open a socket, blah blah. You're done in 5 lines. You got the web page or whatnot, right? It's very easy in Python because there's so many great libraries for that language, and for Ruby, for example, just the same. Indeed, sort of in between the scarcity of traditional systems languages and the richness of traditional scripting languages, it's somewhere in between. And right now we're working on improving the library availability for D. And we have this great project started by Walter, which is simple, just connection with the C libraries that do OpenSSL, that do curl, and that do encryption and all the stuff, which is robust, solid code written in C. That would make little sense to rewrite in D, with all the translation costs. So why not just link to it? Because D talks natively to C. There's absolutely no translation overhead there. So just write the correspondent, the headers, the summaries that link the C code to the D code. And we have a lot of these projects started already. A lot are working already. The community has jumped on this project. And we're sort of getting there, but right now, as of this moment, right now, I can't say that you can just open SSL, just use an SSL link in 5 lines. I got everything I need.
Sure.
So that would be the major issue right now.
I'd like to add that very few programs actually need system level code. But when you need it, you gotta have it. Like, you're not gonna write a storage allocator in safe code. You're not gonna write a malloc in safe code, because you gotta do dirty things like casting pointers around. So, what D enables you to do, instead of being a lockdown language, that if you needed to write system level code, now suddenly you have to write that system code in another language and provide some sort of glue to hook into your other program, and your program then becomes a hybrid of two languages. D allows, by allowing you to an escape way of doing system code, it doesn't force you to switch languages. You can do it all in one language. You don't have to learn another language. You don't have to master another language. You can do it all in one language, both the high-level stuff, the safe stuff, and the under-the-hood system code.
Excellent. What is it about C++ besides the safety, perhaps, as you had said, that's missing from its genericity that you're offering? So, like, for example, Dart's very different from other models that currently exist out in the real world to do structured web programming. How is D going to differentiate itself from C++ to an extent where it's like, yeah, you know, I'm gonna think about trying D out, because for this problem that I have, I'm going to use D. That's my question. I know it's kind of a weird one, but
No, I think it's a completely legitimate question. Let me hijack it, okay?
Okay.
Let me hijack it by saying, again, it's a very legitimate and fair question to ask. However, I think we, historically, the two shared custodians of D, whatever you want to call, so we in the D community and some other programming communities, I think we've historically made the mistake of comparing ourselves too much against other languages. And you know, even in this interview, I mentioned other languages, you know, but just for the means of exposition, saying, you know, I prefer to write the script in this language versus the other. So I would rather, I think it's best to discuss the merits of D and the originality of D.
okay.
Not necessarily by contrasting or look at those guys. I think there's merit in all popular and a lot of less popular programming languages. I think there's just a lot of great ideas, a lot of great work. Dart is awesome. Go has awesome ideas. Not to mention the established languages. So not to mention like Haskell, the sort of the Adobe of all languages, like that took really non-strict lazy evaluation and functional semantics to absolute maximum. So again, I'd rather talk about the merits of D rather than the supposed demerits of any other language. And in that vein, let me say this. I think D does have a lot of things going for it. I think it has a good concurrency model. We're still working on debugging it. I'm sure the D community kind of is having a chuckle right now. We still need to work the kinks out of the all the memory barriers that need to be inserted there, all the correct semantics of multi-threaded code. But I think the basic model is extremely robust, extremely strong, very original. It offers very good guarantees. We have this hybrid system. Even Hans Bohm liked it. This hybrid system in which you use message passing for everything that's safe to pass as a message, and when you really want memory sharing, there's a controlled, limited, and sort of bonding and discipline kind of thing, memory sharing, because memory sharing is very dangerous. So we want to do as little of it as possible and as controlled of it as possible. So I think this model is very appealing. So essentially, let's talk about what D has good and bad, for that matter, as opposed to discussing other languages.
But now, in all transparency, we're doing this interview on the end of day 2 of GoingNative 2012, which was about C++. So I just we all have that on our brain. But that's a wonderful point. So let's do that. Let's focus on that. So you guys, by default, you don't share. It's a no share model, and there's also the Threadlocal. Can you talk to us more about that?
Well, we've decided that unlike in human relationships, it's not nice to share in programming language. And we were sitting at a cafe one time wondering, what the heck are we going to do about concurrency? How are we going to implement Threadlocal storage? What are we going to do about that? And finally, I had an epiphany. We thought, we're going to flip things around completely. We're going to make all storage Threadlocal by default. And that if you want to have something shared between threads, you have to explicitly mark it as shared with a storage class and a type qualifier.
That are transitive.
That are transitive.
Follow pointers. Yeah.
Transitive means it's turtles all the way down. So the idea being that even if D does nothing else with concurrency, all of a sudden, if you have a race condition or a problem, or you suspect a race condition or a problem with inadvertent sharing between different threads, or you have a sequential consistency problem, instead of having to look at every piece of data in your program to see if it's being shared, you only have to look at the stuff that's marked as shared, because those are the only variables and data that multiple threads can see. So all of a sudden, instead of your problem set being this big, your problem set becomes this big, even if we do nothing else.
Wow.
We've shrunk the problem set way down in size.
Excellent.
So that's why I think that we've got a rather unique and excellent basis for multi-threading and concurrent programming. Another thing we've got is we've taken the functional idea of immutable data and brought it into D as a type qualifier. You can say this data is immutable, it's also transitive, it's also turtles all the way down, which sometimes causes people distress because they go, I know it's immutable, I want it immutable, but I just want to change it over here, and will D let me do that? And it's like, no, we draw a stake in the ground, immutable data is immutable data, and transitive immutable data has the absolutely fantastic property is you can share it between threads without synchronization.
Wow.
So you have your immutable data, which is implicitly shareable between threads, and then you have your mutable shared data, which is shared between threads. And so by working with the combination of those two, we really feel that you can cut down a lot on your concurrency problems.
Excellent. By removing the possibility for them to exist in the first place.
Right.
It's brilliant.
Sharing, right.
The idea is not so much to find solutions to problems, it's to design the problem out of existence.
Excellent.
Is our goal. So the problem can't even be made.
So when you guys were thinking about a syntax for this new language, you seem to have gone down the C-style imperative kind of world. Was that chosen because you come from the C++ world, or because you realize that your target audience are going to be, most of us are imperative programmers, we don't program in Haskell?
Well, when I first saw C, I immediately liked its syntax. So it's not so much I was forced to use C and I grew to like it. I liked it from the start. I like it now. I make no apologies for it. D has a C-like syntax because it's a great syntax.
Cool. And that's good. I always ask that because it's interesting to know, like, why do you pick us? Because when you're doing something from purely scratch, you have the ability to do whatever you want with the syntax, make it much more easy to reason about as a human. But you're targeting those who are already imperative mindsets and are used to C, which makes sense. I mean,
well, it has the other advantage in that, it's for a C programmer, it's quick and easy to pick up D because, I know what that is, I know what that is, I know what that is. He only's got to learn the differences. He doesn't have to turn his syntax inside out from what he's used to doing.
Speaking of inside out, let me add this to for your audience.
yes.
We did get rid of the inside out syntax for defining things like pointers to functions and sort of data definitions. So they look a lot more natural indeed. And see, I mean, this has been an acknowledged issue with the C syntax. That all being said, at a point, Charles, it becomes gratuitous to invent an alien syntax just for the heck of it. Erlang, for example, has a lot of interesting ideas in it. It just has this alien syntax that's like nothing else, and it's just out there, you know. And I think I don't care that much. I'm not bothered by syntax a lot. I know a lot of people are, and I also know that syntactic habits take a long time to form, take a long time to change, you know. So for us, it would have been quite gratuitous to say we're going to design a systems language that essentially invents its own syntax from scratch without caring about any tradition or familiarity. So I think it was a quite easy decision to make.
Sure. Now, something tells me that you would not have gotten involved with D if it didn't have some form of advanced template capability. So can we talk about D templates for a little while?
You start.
All right. D initially did not have templates, and it was because I didn't understand templates. Andrei, I'd meet Andrei at the Northwest C++ users group meetings, and he kept hitting me over the head with this until one day I got it. And when I got it, it was like, okay, we need to work on a syntax and a design for it so that it's template programming should be as easy as writing a regular function to sum an array of integers. I mean, there shouldn't be any magic. It shouldn't be difficult. It should be straightforward. And so we cast around and worked at until we found a syntax that we felt made it easy. Because after all, what is a template? It's a type with a parameter. What is a function? Function is a piece of code with a parameter. So really, the template syntax evolved from that, where we just have a function and we add another parameter list, which are the type parameters in addition to the value parameters. And it turns out to be real simple and easy, and people really latched onto that. I think we've got a very readable and powerful template syntax as a result.
Let me add this, Charles, real quick. Let me say this for the record.
Yeah.
I think Walter is one of the language designers with a lot of good taste, because it just so matters, right? So language design is a kind of a weird business to be in, because there's a lot of subjectivity in it. There's a lot of, it's difficult to quantify, like which is this language good, or is it better than others, or it's very difficult and very subjective. And I know a lot. I've done some research in programming languages, and essentially I know people who do language design. I know personally people who do such, and I've been involved with C++, as you well know, for a long time, and I know people who design pieces of language. And I can say that taste in programming language design is a very important trait to have, and a trait that many people think have but don't have. And Walter has this very good eye for kind of good code sitting there.
Yeah.
Although he uses GoTo, by the way.
I do use GoTo.
Let this go on record too. Actually, I use it too, but
some people might argue about whether I have good taste.
So I think he has good taste in language design, and I think he knows. Essentially, when I go to him with a construct, he kind of has an eye for it, and it takes him like 3 seconds to kind of say, you know what, this looks good or this doesn't look as good, and here's what we can make to make it look better. So this is a rare trait, and I think Walter really has it. And I think it's reflected in virtually all aspects of the deep programming language. There's not a lot of places in which the syntax looks kind of, it's really nicely, it has a really nice polish to it.
We really wanted simply the code on the page to look attractive. That was, I think, of paramount importance, that it just simply looked nice, because in my experience, a design that looks nice tends to be bug-free and to work as expected. If it's looking wonky looking, it's most likely wrong. And sometimes code in other languages, it just there doesn't seem to be any way to lay it out so that it looks right on the page. And to me, that means there's something we can fix about the syntax.
Certainly. Well, yeah, I mean, it certainly is. It's a streamlined. It's very clean from my brief experience with it. Now we live in a world with so many different models executing at any given time. I mean, let's take for example, you mentioned that D kind of seamlessly interoperates with C, but what about with other systems written in similar yet very different languages? Like, how does that work? Is my question. So let me be more specific. Let's say that I want to write. I want to use D because I get the native experience. I get type safety. I get memory safety. I get concurrency. I don't have to deal with all the nightmare that I normally have to. But the system that I'm targeting, it's a foreign type system. It's a foreign model. How does that interoperation work? What kind of bridges exist?
The lingua franca of the programming world is C.
Okay.
So it's like if a German person goes to Japan, they converse in English because neither of them know the other language.
Yeah, I thought they were speaking C. Yeah.
Or they converse in C.
Yeah. Wait, start.
Okay. Most languages have an interface to C. D also has an interface to C, and that's really the bridge between languages. In fact, it's so much that even if C disappeared entirely from the planet, everyone would still communicate through the C ABI because that is the lingua franca of the programming world.
Excellent.
Definitely. I mean, let me add to that. Definitely. So that, modern systems need to actually sit on more than one machine, which means communication across network and process boundaries. We have in Works, we have actually it's been submitted to Apache just 2 weeks ago, a binding for Thrift, which is a lightweight protocol for communicating data across machines and processes, written in arbitrary languages. So there are a lot of Thrift bindings for the likes of C++, PHP, Python, you name it. And once D is in that ecosystem, it can be successfully used as a service, service implementation language, and you drop it on a machine, communicates via sockets, and it, just Thrift does all the communication work. Also, there's a lot of interesting possible interoperations. I'm talking in the future tense here. We have this sort of variant type, which many other languages do have, which is a mapping of sort of a discriminated union of whatever types you have in some interpreted language you are communicating with. For example, Lisp has its own, like it's either a list or an atom, and an atom can be a string, can be an integer, etc. So it has a well-defined universe of types, and it's relatively easy with this variant, which is a library we have. To interoperate and communicate with pretty much any interpreted language, as long as there is understanding about the data layout, and that includes, of course, database systems. Again, I'm talking the future tense because right now there's no interpreted language that has such a bridge implemented, and there's work on database connectivity, but not finalized.
Excellent. Now, D's been out for what? It's version 2 now, the compiler, D2?
The main version 2, yes.
And so you have actually a pretty vibrant community, because I can see that on...
Things are happening,
yes.
yeah.
I mean, it's pretty amazing. How are people using it in their day-to-day worlds? Like, what kind of applications are you seeing? What kind of services are you seeing? What kind of systems are you seeing?
It's kind of creeping into companies from the bottom up. It's sort of like, you build the dike around your company, we're only going to use these languages, and D is kind of seeping in through the cracks. And that's kind of neat to see that people like it enough that they evangelize it and bring it into their companies. We've also seen an explosion in contributions to D, which is a team effort when we put everything up on GitHub. Now anybody can check out the project on GitHub, fork it, create their own patches, generate pull requests for the patches, and this is all contributing to the explosive growth and improvements in D. So it's really a very much community-driven thing. And people work on the aspects of libraries and things like that are important to them, and then we fold it into the main line.
Awesome. Now, I know people who are C++ people that really like D and want to be able to use it, but the question I want to ask you is interoperating with C++. If C is a lingua franca, why is it so hard to interoperate with C++? Since, I mean, C and C++ are very close allies.
I think with both answer the same
Okay.
thing. It's not all that difficult, and we've made great inroads into that. We do. This is Microsoft. This is the Channel 9 guy. So we do have interoperation with a COM style object model, COM like object model.
Yes.
So we interface absolutely seamlessly with that memory layout, which means you can connect to interface. You can get a pointer to an interface with that layout. You can call methods through it, and it all goes smooth. There's no exception transportation, but this is sort of a known issue across large fragments of systems. And we are able to say extern C++, qualified declaration, kind of the compiler applies the correct mangling to the name and all that. What we don't do is connectivity with C++ templates, because it would really require incorporating a C++ compiler within the decompiler. But at the same time, would you expect to invoke a C++ template from Python? Let's say I'm going to instantiate vector of int from Python or Ruby or whatnot. I mean, I think it's a reasonable limit to have, a reasonable boundary. To the short answer is there is good connectivity with C++ already, and there's some more that we're looking at.
Yeah, we're currently looking at supporting C++ namespaces.
Okay.
Right, so there's some work on that. But
I mean, and the only reason I really bring that up is not to try to find a challenging question, but more to, which is of course hard with people like you. I mean, but really what I was kind of curious, there's a lot of libraries out there that have been written that are very, very highly performed 3D, like 3D physics libraries,
Right.
that may or may not employ templates in their implementation,
Right.
that are written in a different language,
Right.
that I would love to use from D and have it run in my isolated, protected context, and I have this nice experience of developing my system and not really having to worry too much about that world. That's
Yeah, the pattern I'm seeing is that all of these libraries come from Fortran, like high-performance computing, come from a Fortran kind of background, or they inevitably are going to have a sort of Fortran-ish or C-ish interface to them. And there's a lot of good C++ code that sort of wraps these libraries in a nice C++-specific interface. C++ is great at making it comfortable to use these abstractions. And hopefully so, in my opinion, so is D. All of these wrappers have no value to D as much as they have to C++, client use. So we are not that worried about wrapping those libraries in their C++ form, like these advanced templates and these, for example, the dimensional analysis. You don't want to wrap a dimensional analysis coming from C++. You can do it in D, and it's sort of a D specific manner. So I'm not that worried. And actually, there is a Google Summer of Code project last year, a scientific library for D that actually talks to BLOS natively and just connects to it, and it just used the high-performance library in there. And it also has a fallback mode for testing purposes if you do, for whatever reason, can't use BLOS. There's definitely work in that area, and I think the proposition we're having is pretty good.
excellent.
Now, there are some excellent C libraries out there built by professionals, such as the crypto libraries. It would be crazy to rewrite those in D. These guys know what they're doing. They've spent a lot of time at it. It only makes sense to simply they present a C interface, and we have D just use the C interface to them.
And the one thing that could be done is to make them safe. I told you there's safe, there's system, but there's trusted in between. So you can say, OpenSSL is kind of a pain to use from just the sheer C interface. It's kind of nice to have a bit of just a layer of nice to have functionality on top of it. And it's also nice to have a bit of safety in the interface. For example, I look at there's this library for URLs, for downloading data via HTTP and FTP curl. So the so-called libcurl. So it has all these void star, and it has an integer that tells you what the void star's type is. And all of the stuff is essentially unsafe by definition, and it could and should be wrapped in a high-level interface, which actually has been done. The code that does all that very nice. It makes you can really download stuff very easy, either in a loop or in function call. I think it's either ready to be accepted or has been merged already.
It's been merged already.
Great.
Excellent.
It's an example of the right way to do things.
Yeah.
Perfect.
So you have the C interface. If you do want to do void star things, there's just the C header translation, which is very it's very bare bones. But if you want to do the kind of the safer way, you actually use the wrapper, which adds next to no friction there, and you can have guarantees, and it looks and acts and works much better.
It's excellent. Now, one of the words we haven't used, one of the words we typically never use when we talk about native programming languages is productivity. Thus, the advent of these languages that run in a virtual machine that abstract away most of the complexity that happens at that level. So it sounds to me like D could be one of the world's first native languages where you throw in another P. So you get power, performance, power, and productivity. Is that fair enough to say?
It's a very nice compliment, and we hope definitely it's on the agenda. It's definitely our intent. It's much more difficult than it may seem. It's extremely difficult to design a language that can work with one molecule and one cathedral in the same program. Very difficult, and there's a lot of things that go into it. But by and large, I think Walter's taste has worked there very well in making essentially a very seamless and compact. In proportion to its power, a very compact way of being able to discuss about very low-level things, and about very big, modular, nice, productive, easy to use, easy to play with, easy to prove properties about things.
Absolutely. Well, I mean, the Hello World sample is incredibly easy.
And it's correct.
And it's correct.
That's correct.
So, I mean, in some sense, it looks like when we talk about things like going native and go native, and native is now becoming much more interesting because it is a machine-driven future. People who are skilled at those higher level languages, where they have these great tools around them, like C# and Java, for example, the tooling around them is equally important as the language, especially the libraries. And the compilers and all the stuff that happens inside of your IDE. Do you guys have that sort of
tooling infrastructure.
Support. I mean, do you like?
We don't.
Okay.
This is the bare truth. We don't. But here's the thing. Just last year we've put the thing on GitHub. There's been an absolute craze about contributing to the compiler and the language. It's been whichever way you count it, it's been half a dozen a day of commits and stuff. So it's been absolutely crazy.
Okay.
There's no doubt in my mind that if we reach a certain critical mass, there's going to be things are going to happen in that area too. And we're already on that road with the library support. We're not yet in that road with large corporations investing in IDs and such. So I'm glad to know you inside Microsoft. You're my contact inside Microsoft.
Well, to be honest, I was just playing around with trying to use a D projection into WinRT.
Actually, before you get into that, I gotta advertise this Visual D thing.
Please
right?
do.
Yeah, so there is a Visual D plugin for Microsoft's Visual Studio. So I haven't used it because I mostly at work I use the X word Unix, right? So my understanding from people who use Visual D is that it is entirely adequate. It's not brilliant and it doesn't do like the awesome things that that Visual Studio does for C++, because it's been years of great teams working on it. But it is adequate already and it's making progress and people are using it and are happy with it. So definitely there is progress in that area. I have no doubt again that once we kind of prove our way and we kind of say we have a stable compiler, we have a good start, a good attack on libraries, we have essentially an answer to the big problems that are out there in front of any programming language. Once that happens, there's tools are going to follow, people are going to follow, they're going to come.
Absolutely.
There's also an Eclipse plugin for D.
Okay.
Right.
And there are configuration files for most of the popular editors, or code editors for D.
Right.
Which actually brings up an interesting point. Can you use D to write an Apple iPad app since they have?
Good one.
I would just be curious because of the
Yeah.
the C lingua franca.
Right.
Has anyone done that?
To my knowledge, nobody has produced an iPad app written in D yet.
Okay.
But also there's the GDC connection, the GCC backend with the D front end, which Ian Bakla is doing such a great job at. And essentially we're really hopeful that we're going to integrate the D front end within the GCC mainline with 4.8, I think, the next version. So essentially once that happens, essentially the backend of GCC is going to serve any D program just as well as it serves any C++ program written on with GCC. So there's going to be access on those devices. But at this point, all of this is wishful thinking and hopeful talk. But definitely things are happening.
Good, and that's why that's why we're talking to you. We want to know what's going on with D.
Yeah, we understand that the iPads and the tablets and the ARM devices are critically important for programming.
Yeah, and in that world, it's nice not to be constrained inside a virtual machine on top of another virtual machine called an operating system.
What about the Windows tablet? It has a pretty neat interface to all languages there are.
It is,
native or not.
And the beautiful thing is that WinRT is native.
All right.
WinRT is native. It's a
And
native
it brings
API.
COM back into the spotlight. How about that? It brings COM back
It does.
into the spotlight.
It is a calm renaissance, man, and that's not a bad thing.
It's good we interface with COM, I guess.
That's great.
COM is a great interface. I
Yeah.
was always kind of
Yeah.
disappointed it kind of went out of favor. I'm glad it's back.
Oh, it's back, and it kind of makes sense, right?
It's a neat, simple interface and very flexible and effective.
Great. So we will probably see people writing D Windows apps.
So.
Certainly possible.
D was
Definitely.
definitely designed to properly support COM programming.
Excellent, man. Well, hey, I guess the last question I'll ask is sort of, what are some of and I'd like to ask each of you this, what is the hardest problem you're working on right now related to D?
The hardest problem is managing our growth in users, and they all need support and help. So the hardest problem is growing from a small operation to a larger operation with a better organization that requires. And so, our biggest problem is probably growth. We're growing fast and we need to learn how to handle it.
That's a good problem to have.
Is a good problem to have. And actually, yes, definitely, that is the high level, the MSB, the most significant bit of things. Growth, and that implies a lot of things. I personally have huge ambitions with D, and I'm sure Walter is with me. I don't want 10,000. Probably we have a couple of thousand users. I want 1 million users. I want to make no compromise there. I'm aiming for 1 million users. to have 1 million users, you got to have scale and capability for 1 million users. Okay, we don't have that. If as Walter said, if tomorrow 1 million users started using D, we'd be dead. We'd be lynched soon, right? So I want to build capability and organization and structure for 1 million users. And I'm not kidding. I'm not exaggerating. If you aim for 1 million, you may get 100,000. If you aim for 10,000, you're not gonna get. See what I'm saying? So we want to aim high. Our ambitions are high. The language is very well designed. It's a very powerful language. The implementation quality is not on par with the design. Many people confuse the two. Many people come on the news group and say, hey, this language is badly designed because, I did this and it has exposed a bug and it doesn't work as I expected, it doesn't do what it should, and so on. I think the design is very robust. And, as any language design, it has a few seams here and there. There might be a rough spot and whatnot. I don't think it has anything where like, oh my God, what were you thinking when we did this, right? The implementation does have some, oh my God, places. So we want to bring quality to, I think we must, as a survival means for the 1 million users who are yet to come, improve the quality of implementation to the point there's no major bugs, no regressions, no nothing. The language works as advertised for any, all combinations of features people try. We're not there yet, but definitely, if you look at the graph of bugs, you're gonna see there's a huge improvement there.
Excellent. Well, hey.
And the D community knows this too, and an awful lot of the action going on GitHub right now is going after everything that people have complained about. We're going to nail it all down.
Excellent.
dlang.org.
dlang.org. We'll put the links will be on this, and people should play with it. And I'll have some questions from them next time I see you.
Thanks very much, Charles.
Cheers,
Thanks
you guys.
for having us.
Of course. Good luck, and come back on Channel 9 soon.
Thank you.
That was really great.
Right on, man.
So I really thank you for having had that conversation and share with all of us. So do you have some information? I mean, I'm really curious about that, the language. I will enter in the website you mentioned, but do you know some facts about the language being used in the real world?
Absolutely.
Real world projects?
Well, I think one of the most recent real world uses is the D forums.
Okay.
So the official D forums are written in D.
Already, didn't know that.
So on the server, I mean, there's D code running that generates HTML. They get sent down to the client.
That's great.
It's very, very fast. Very, very fast. I mean, in fact, forum software is typically pretty fast, right? But this is super fast. At least that's been my experience. Maybe it's just, I'm got too much native on the head.
I see.
But it's really cool to see it. And it still needs to be tested. It needs to be tested in terms of can it scale huge amounts of requests. I don't know if the D forums are that popular. There's certainly a lot going on there, which is great to see. But anyway, that's one example. Another example that's actually a little bit on a fringe is somebody's written or started to write a D projection, as it's called, for Windows 8 Metro.
Oh, really? Wow.
Now, as folks know, COM plays a pretty important role in that world, and D is actually pretty COM friendly.
Okay.
In fact, COM is what you'd need to use to interoperate with C++.
Absolutely. And
Because,
other languages, JavaScript and.
Unfortunately, D doesn't really communicate easily with C++, right? They'd have to write a full C++ compiler front end if you were able to do that. So templates they don't